In this video, we're going to discuss percent yield and how we determine how much of a chemical reaction product that we get based on how much we should have gotten theoretically. So in any experiment, it's not going to be perfect. You're going to get some amount of the product that you actually get. So some mass of actual yield of your product. And then by doing a stoichiometry problem, you can figure out how much of the product you should have gotten in a perfect world. This theoretical yield has to be calculated. It's perfect world. This value is the value that we actually get in the experiment. This is what we actually get. So looking at this example, it says that we reacted zinc and chlorine to give zinc chloride. And it says that we begin with 58.9 grams of zinc, so that's one of our parts that we're dealing with, and excess chlorine, meaning we've got plenty of chlorine. What's the theoretical yield of zinc chloride? So we want the theoretical yield of zinc chloride. That's what we're trying to find. Now, somewhere in here it's going to give us an actual value that we got experimentally. We can't determine that if they don't tell us. We can get a theoretical on paper perfect world value, but they have to tell us what our actual yield is. So always find that and make sure you know what that is. You could go ahead and start your calculation of percent yield using that, because we know that percent yield, as it's set up above, was going to be the actual yield over the theoretical yield times 100. Now, this is not percent error, guys. We are not subtracting that top value from anything. That top value is simply how much we actually got. The bottom value is perfect world, which we have not calculated yet, but we do know this right now. We know that there are 115 grams of zinc chloride that were actually isolated. They may say isolated, they may say actually produced. There's a variety of ways they could state it, but we need to make sure that we find that value. So we've got this set up. What we're going to try to find now is this bottom value here. Let's do that with a calculation. We know that we're starting out with 5.89 grams of zinc. And we know that zinc has a molar mass of 65.38 grams of zinc per mole of zinc. And now we can use our mole ratio. We know that it's a one-to-one reaction, so all we're trying to do here is switch substances. We've got 1 mole of zinc for every 1 mole of zinc chloride that we're trying to find. And finally, we need grams of that zinc chloride, and we add up the molar mass of that, and it's 136.28 grams of zinc chloride per mole. And we come up with 122.77. Now, if this were not asked for specifically, because sometimes they don't, sometimes they'll just say, what's the percent yield? They won't ask for the theoretical yield. If they don't, we don't need to report this as a USS value. We just need to plug that into that bottom equation. However, this time it did ask for theoretical yield, so it asked us for both of them. So we do need to report this USS. It looks like we need 3 sig figs over here, so 1.23 times 10 to the second grams of zinc chloride is our theoretical yield. So that answers the first part of the question. Now, the second part of the question wants us to give the percent yield. So we've already put down the actual yield on top of 115 grams. Now we need this theoretical yield we just determined. Now be careful because you never want to use a rounded value, remember. So let's go back and use this value to put in the bottom down here. We don't want to use a rounded value in our calculation. AP rule is don't round till the end. So the only reason we rounded it above is because it was actually asked for as a reportable value. So when we divide this and multiply by 100, 3 sig figs, we get a value of 93.7% yield. Remember, we do not put money, percent, or molar mass in scientific notation. So there's the percent yield in this problem.